Cambridge closes in 1665. Young Isaac Newton retreats to Woolsthorpe Farm. In isolation, he invents calculus, explores light's nature, and begins his revolutionary work on gravity. 18 months of plague yield the foundations of modern science. Newton's prism experiments shatter centuries of misconception. White light, he discovers, is not pure but a hidden spectrum of colors. The prism merely separates what already exists within. His 1672 publication ignites fierce scientific controversy across Europe. Newton's Principia Mathematica, completed in 1685 and 1686, stands as science's most transformative work. Within its pages, he establishes his three laws of motion, derives Kepler's planetary laws, explains Earth's tides, and predicts cometary returns, all through mathematics he himself had developed. Newton casts his algebraic solutions into geometric proofs, the language of mathematical authority. His Principia becomes deliberately impenetrable, a fortress of classical rigor that contemporaries cannot refute, yet scarcely comprehend. Newton's three laws of motion form the bedrock of classical mechanics. An object remains at rest until a force acts upon it. Force equals mass times acceleration. Every action produces an equal, opposite reaction, governing everything from billiard balls to distant galaxies. A cannon atop a mountain fires horizontally with increasing force. Slow shots fall earthward. Faster shots travel further. Fire with sufficient velocity, and the projectile falls perpetually around Earth's curve, achieving orbit. Gravity and orbital motion reveal themselves as one unified phenomenon. Edmund Halley visits Newton in 1684, learning of his revolutionary orbital solutions. Recognizing genius, Halley edits the manuscript and finances publication when the Royal Society falters. Without this friendship, the Principia might never exist. Halley applies Newton's gravitational theory to historical comets, discovering that observations from 1531, 1607, and 1682 trace identical orbits. The same comet returns every 76 years. He predicts its 1758 return, vindicated long after his death. Newton's system had unlocked the future. Newton's inverse square law reveals gravity's elegant truth: force diminishes with distance squared. This single relationship, combined with his laws of motion, mathematically derives Kepler's empirical observations. Where Kepler described planetary motion, Newton explained its fundamental cause. Newton becomes master of the Royal Mint, pursuing counterfeiters with scientific precision. He gathers evidence and prosecutes forgers with the same rigor he applied to physics, sending coin clippers to the gallows in London's criminal courts. Gottfried Wilhelm Leibniz independently developed calculus as Newton did. Their bitter priority dispute divided European mathematics for decades. Ironically, both were right. Leibniz's notation, dy/dx, the integral sign, survives today. Newton gave physics its laws, Leibniz gave mathematics its language. Every rocket trajectory and satellite orbit operates through Newton's laws. The Apollo moon landings exemplified Newtonian mechanics, parabolic paths calculated from equations published in 1687. Newton's gravity still governs our solar system, with Einstein's refinements mattering only at extreme velocities. Newton's plague-year isolation at Woolsthorpe yields discoveries that transform science. From prisms splitting light to the Principia completed in 18 months, his laws of motion and universal gravitation still describe our physical world today. I am Takku. A falling apple unlocked the single law that governs every planet in the cosmos. Subscribe to Wisdom of Takku, because the universe hides its deepest truths in plain sight.